This conference will now be recorded.
Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs. With our Java examples interview question series, this is a third video I'm going to prepare. And so far, we have seen different examples like that. This GCD of two numbers and LCM of two numbers, we will do it later. So I'm just making it no fill like this. Okay. Other than that, most of the things we have already seen that up to 22. Today we will see some more 8 to 9 more functions in this particular, 8 to 9 more programs in this particular video. So without wasting a time, let's start. So the next question is Java program to calculate the power of a number. Okay, so power of a number means, let's see, um, 2 to the power 2 is equal to 4, 2 to the power 3 is equal to 8, 2 to the power 4 is equal to 16, something like this. So how to do this? So let me create a Java class over here, and let's do it quickly. And I'm giving a let's see, power concept. Okay, select the main method and click on finish. So how will you solve this problem? So first of all, let's see, I'll maintain one variable that, let's say I want that example something like this, that 3 to the power 4. It means 3 to the power 4 means 3 multiplied by 3, right? 9, 27, and then 3. So is equal to 81, like this. So 3 is the base and 4 is the exponent. So I'll maintain two variables. One is base is equal to 3, and I'll maintain one, let's see, exponent is equal to 4. Like this, I'll be maintaining two variables. And okay, initially I'll maintain a long variable because the 3 to the power of 81, but sometime if we have a larger number, you might get a long number. So better we store the result in long instead of integer. So I'll maintain one result initially is equal to 1. Let's see. Okay, and then I'll write one while loop, and I simply say that if your exponent variable that you have created is not equal to, sorry about that, one second, sometime my eclipse, okay. So if your exponent is not equal to 0, right, because 2 to the power 0 is equal to 1 to the power 0 is equal to 1. So what we have to say that if it's not equal to 0, then only we have to come. Then only we have to do the calculation. So I simply say that, okay, result is equal to, or I say that, okay, result multiply by is equal to base, right? So result is equal to result multiply by base, or you can write something like this also, result multiply by is equal to base. So this is just equivalent to this, result multiply by base. You can write it like this as well, or you can write it like this as well. And then what we have to do, guys, so we have to keep decreasing the exponent value, because somewhere we have to break the while loop. So exponent, let's say I'm starting for 4 and is not equal to 0. So result is equal to what? Result multiply by base. So 3 multiply by 1. Okay, so my result will be 3 in that case. And then I keep decreasing the value. So what I'm going to do that, okay, I simply say minus minus exponent over here. And that's it. And then I'll come out of my system.out.println. I simply say that I simply print the result directly over here, right? So let me quickly check. Yeah, it's working or not. Let me check. 3 to the power is 81. Perfect. And let's see, I'll say 2 to the power 4 will be 16. Yes, it's 16 over here, right? So I hope this very simple calculation. If exponent is not equal to 0, then you simply say that result multiplied by result is equal to base. Okay, and you just keep multiply by with the result and keep decreasing the value exponent, right? You should not increase the value, you have to decrease the value to break the while loop. As well as you have to write it like this, 4 multiplied 2 multiplied by 2 multiplied by 2, like this. So 4 times you have to do that. So 4 minus 1 3, then minus 2 minus 1 2, then 1, like this. You have to do that. Now one more thing, if you write base is 2 and exponent is 0, then what will happen? It means 2 to the power 0 is equal to 1. So in mathematics, what whenever the power is 0, of any number is equal to 1 always. So remember this thing also. That's why I have declared result equal to 1. It means if exponent is equal to 0, this condition is not satisfied. It will not come inside the while loop. It will simply print a result over here. Result is 1. Perfect. So let's see if I'm saying 2 to the power 9, that will be a long number over here around 512. If I'm saying that okay 2 to the power 30, then I'll be getting a very good long number like this. Okay guys, so it's absolutely working fine. Very simple concept. There is no rocket science. Same thing you can do with the while loop, with the for loop also. That is up to you how exactly you can do that. Yeah, one more thing you can use that. There is a direct direct function is available. You can simply say that if you really want to print, you print system.out.println. You simply say that okay, math is a class, a dot power function is there, and it's saying that okay, what is your base? What is my base? My base is this. And what is your exponent? So whatever the exponent that you are saying, and that's it. And if you let me comment it out these days, you can directly get the value over here. Okay, so math this and the base is 2. I'll do one thing. The exponent is let's say equal to 4, and now you run it. See, I'm getting 16.0. Perfect. So likewise also you can simply do that. So math dot power will give you a double, so that's why you are getting 16.0. So if you increase let's say 2 to the power 40, it will give you a long number. You can see that 1.0 up to E12. So it's not decimal, it's not 1.0 only, right? It's like it's a huge number over here, 2 to the power 40. So it will convert into decimal number like this. Okay, so like this also you can simply do that. But I don't prefer it at the time of interview. People are expecting this to solve it like this. Okay, that's it. Now next function. So this is also done. I'll just make it a green color. Okay. Now the next thing is check whether number is palindrome or not, right? So you need to check the number is palindrome. So what do you mean the palindrome number? Palindrome number means the reverse of that particular number is also same. So just let's like 1 to 1. If you reverse 1 to 1, that is also a same. So let me create a class over here, and I simply say that okay, palindrome number. It's a very simple question and very evergreen interview question. At a time of interview people might ask you, doesn't matter you're going for Java, Python or whatever. Okay, for a fresher also it's like it's quite easy method or easy question. So I want to check that okay, that particular number is palindrome or not, right? So how to do this? So give me an example of let's see, I'll be taking one example. Okay, 1 to 1 is a palindrome number, right? So I'll do one thing. I simply say that okay, integer number is equal to 1 to 1. I want to check that okay, this is a palindrome number or not, right? And then I'll maintain some more variables. Let's see. Okay, so I'll say one thing. This is my reverse is equal to initially 0. I'll maintain one more thing. And okay, let it be like this. I simply say that okay, while number is not equal to 0, right, then only we have to come inside the while loop. And I simply say that integer n is equal to whatever the number that you are getting, a modulus 10. It means you get the remainder out of it. Okay, and first you need to reverse it. So you remember that we already done the reverse. Okay, reverse formula. Then how will you reverse it? So I simply say that now whatever the reverse that you are using over here, reverse is equal to reverse multiply by 10 plus whatever the remainder that you are getting, n, right? And then the same number. Okay guys, the same number is equal to number divided by 10. In that case, what will you get? In that case, you will be getting your reverse number over here. And I simply print the value of number over here. Let's see, like this. So if you run it, you okay, you're getting number is equal to 0. So I'll do one thing that I'll maintain one more variable over here that actual number is equal to number. Okay, actual number is equal to number. And what I'm going to do, I'll simple instead of print out output print, and I simply say that okay, if whatever the Let me just print system.out.println. Are we getting the right reverse number or not? So my right reverse number is what, 121. It means we have reversed it. Then I'll put a condition over here that, okay, if your original number or your actual number, okay, which is equal to the reverse number, it means that is the palindrome number. I simply say that, okay, system.out.println, this number, I would say this number is a palindrome. Else system.out.println is not a palindrome. You getting a point? So first I'm reversing it and then I'm comparing with the actual number. So why I'm taking this actual number over here? You could have seen that, okay, hey, I can take this number also, but no, this number with this particular while loop, I have changed it. So the number finally I'm getting 0, okay, after this particular logic. So better you store another variable over here and then you match it. And then let's see 121 is a palindrome or not. It's saying this, no, number is not, sorry, this origin actual number, sorry about that. Okay, now you run it again. It's saying yes, 121 is a palindrome number. But if I say that, okay, 120 or 122, 122 is not a palindrome number, because if you reverse this guy, you will be getting what, 221. 221 is not equal to 122. So it's not a palindrome. It's saying it's not a palindrome, right? So let's see if I'm passing 1331. The reverse of 1331 is what? 1331. Both are palindrome. So if you run it, see we are getting, it's a palindrome number. If I'm passing only 1 over here, 1, the reverse of 1 is always 1. So that is also a palindrome number. That is the shortest palindrome number. We can see that in positive integer, right guys? If I say that, okay, 100, so 100 is not a palindrome number, because the reverse of this, what? Reverse of this 1, which is not equal to 100. So that's why it's not a palindrome. So remember guys, 1331 is a palindrome number. We can check with any number. Likewise, you can simply do that. Some people, what they do that, okay, they convert that number into string and then they reverse it with the string buffer or reverse function, and then they compare. No, that is what people are expecting. People are expecting to write this particular logic. Okay, so don't convert unnecessary into string. So the string dot value of, you will write, you pass this particular number, you convert that into a string, and then you write one a string buffer dot reverse, right? And then you compare that, okay, yeah, it is equal to reverse or not. If it is equal to reverse, that's a palindrome number. But you should not do it. People are not expecting this thing. Okay, perfect. Now the next question. So palindrome we have seen. Palindrome we have seen. Now the Java program to check whether a number is prime number or not, right? So prime number is also a very common thing. I'm sure that, okay, most of the people are already aware about it. So I simply say that prime number. Select the main method, click on finish, and prime number. So what do you mean by prime number? Prime number means a number which is divisible by only two numbers. One is 1 and itself, right? So prime number means a number which can be divisible by only by 1 and by itself. Example, 13, 17, 29, right guys? 13 is a prime number. Why? Because it can be divisible by 1 or it can be divisible by 13 only. Same thing, 29, 17. 29 cannot be divisible by anyone except 1 and the number itself. So that's why this is a prime number. Now, how will you write a logic for prime number? So let's take one example. First, I'll maintain one number. Let's see, I want to verify the 13 is prime number or not. And then I'll maintain one Boolean flag also, is equal to, let's see, initially it is false. If it is, okay, I'll compare later on. And then I'll write a simple for loop over here. I simply start int I equal to 2, because 2 is the lowest prime number, guys. Remember this thing. Okay. So I'll start with 2. I should not start with 1. 1 is not the prime number. Okay. So 1 we don't compare with the prime number. So 2 is the lowest prime number that we have to start. So if someone is asking you what is the lowest prime number, 2 is the lowest prime number in positive integer. So I simply say that, okay, I is equal to 2, and I'll write I less than is equal to what? Whatever the number that you are getting, right? Less than equal to number divided by 2, and then I simple write I plus plus, increase the value of I, right? So I less than number divided by 2. So whatever the number you are getting, 13 divided by 2, it means up to 6 times loop will start from 2 to 6, right? And then I'll put a condition over here for the prime number, okay? For the non-prime number actually, so I simply say that, okay, if this particular number, the remainder with I is equal to 0. Why? Because whatever number, like 13 that you are getting, and I is equal to 2, it means if it is divisible by 2, let's say I'm passing 14, which is divisible by 2, is equal to 0, it means the number is divisible by 2 also, and number by divisible by 1 also, and number by divisible by itself also. So in that case, it's not a prime number. So what I'll do, I immediately make my flag is equal to true. And then I got that, okay, yeah, this is not a prime number, and break the loop immediately. I'll come after the loop over here and simple say that, okay, if what? I simple say that, okay, whatever the flag value that you are getting. So let's see if I'm passing, let's see if I'm passing 14 over here, right guys? If number is 14, which is divisible by 0, yeah, flag equal to true. If flag equal to true, it means it's not a prime number. So I'll do one thing, I'll make it not over here. And I simple say that, okay, system.out.println, if it is flag equal to what? True, it will make it false. And I simple say that, okay, yeah, that number is a prime number. So I simple say that, okay, number is a prime number. Else system.out.println, I simple say that, okay, is not a prime number. Okay, so 14 is not a prime number, so it should print is not a prime number. Perfect. Now if I'm passing, let's see, 13, in that case what will happen? So 13 is not at all divisible by 0 at all. It will never be true. It will never break it. It will come over here, flag equal to 1. Flag is always false. It will make this particular flag equal to true. This entire condition will be true now, just because it is not and is a prime number. So that's a very simple logic that you just need to write. Let's check some other prime numbers. 29. So 29 is a prime number. Okay, if I'm passing, let's see, 2. 2 is a prime number, right guys? So 2 is also a prime number. If I'm passing, let's see, 1, with 1, let's see, is a prime number. It's taking that. Okay, yeah, with 1 it should not give you. So we can put a condition over here that, okay, if number is equal to 1, then simple is not a prime number, because it's according to this particular logic, it's considering that, okay, 1 is a prime number. But I think according to my understanding, you guys tell me, 1 is a prime number or not. We just need to check it again. But according to me, the lowest prime number is 2, not 1. Okay, but you can handle this condition, that's not an issue. But better we start I equal to 2 over here and like that. Perfect. So let's see, I'll check with some other prime number, that is 37. 37 is only divisible by 37 and by 1, so it's a prime number. Simple. So likewise, you can simple write a logic for prime number. Very simple. Maintain, you just need to check it's equal to 0, then it means it's divisible, otherwise it's gone. That's it. Okay guys, perfect. So this is also done now. So I'll just make it green. Display prime number between two intervals. Yeah, sometimes people will ask you that, okay, hey, there is a range, like let's see, between 10 to 30, how many prime numbers are there? Between 20 to 40, how many prime numbers are there? Like that. So how will you do that? For doing this, let's create another class over here. And I simply say that, let's see, prime number in interval, in a particular interval or in a particular range. Click on finish. And what I'm going to do, it means, let's see, the prime number I have to find between 20 to, let's see, 70, or let's say 20 to 50. How many prime numbers are there within this particular range, right? So the low number is your lowest range is equal to 20 and your high range is equal to 50, like this. Okay, I'll maintain two variables over here like that. Then I'll put a condition over here that if while condition, it means if your low is less than high, then only you have to proceed further, right? Obviously, it means your low range is less than high range, or your high range is greater than low range, then only you have to proceed further. And I'll do one thing first. Immediately I'll maintain one flag over here, that let's see, same thing, flag is equal to what? Flag is equal to false, right? And then same condition I'll be writing my for loop. I'll start like int I equal to 2, I less than what? The low divided by 2, and then I plus plus. And then I'll put the same condition, that is for non-prime number. If this particular low, the number that we are starting from, is a modulus I is equal to 0, and then I'll just make my flag equal to true in that case and break the loop. Same logic. Now you must be thinking that, okay, why I'm not considering high over here? Because it will keep checking the loop with this particular while loop up to this lower number is less than equal to high. So if your high range is 50, it will keep checking up to 50 over here, 49, then finally 50. So that's why we have tackled this particular condition over here like that. Okay, and that's it. And I simple put one condition over here, one if over here, that if not same thing, flag, right? And I simple say that, okay, system.out.println, I just need to print what? I just need to print low plus with some space over here, right? Now, if you run this, what will happen? So let's see. Let me run it again. See, it's not printing anything because it's not coming over here between 20 to 50 because we are not increasing the value of low. So I'll do one thing, low plus plus, and now let's run it again. We getting the right output? Yeah. So 23, 29, 31, 37, 41, 43, 47. Yes. So this is the right answer for that. Between 20 to 50, these are the prime numbers are available. Right, guys? Because you have to increase the value of low, then only this particular while loop will be executed next time, right, guys? Otherwise, it will never come over here. Okay, so that's why this line is important to write. Perfect. So simple. Display the numbers between these two numbers. Display the prime numbers between these two numbers, these two intervals. You can simply do that. Okay, so that was easy. Now the next question is Java program to check Armstrong number. Okay, Armstrong number. I don't know you guys are aware about it. As per my understanding, I just forgot Armstrong number. Okay. The power of the sum of all the powers. Okay, so let me create a class and Armstrong number. Okay, main method, click on finish. Okay, now Armstrong number means, guys, so Armstrong number means, let's see, my number is something like this, 153. Yes, is how will you check it's an Armstrong number? So for Armstrong number, what you have to do, that you have to write it like this, 1 to the power 3. Okay, so it means multiply by 1 3 times, like this, by 1 by 1 plus 5 also multiply by this, and 3 also multiply by 3 times, and you take it. What will you get? 1 plus 125 plus 27, that is equal to 153. This is called Armstrong number. So 153 is a okay, is an Armstrong number, like this. Some other example I remember, 371 is also an Armstrong number. You can calculate it. Okay, so how will you do that? You have to write a logic. It's little complex, but simple. The same formula you can apply. I'll do one thing. I'll simple maintain one number. Let's see. This is my number is 153. Okay, and I'll maintain one more. Remember that actual number is equal to number, because number I'm going to change in my while loop, and then I'll write my while loop over here. I simply say that number, or okay, I'll say that okay, this actual number I'll apply, or you can apply on number also, both are same thing. So let's see, this time I'm taking actual number is not equal to 0, like this. Okay, you have to write it like this. And what I'm going to do, I'll maintain one reminder n, or yeah, n is equal to what, that whatever the actual number that you are using, actual number modulus 10, you get the reminder, and I'll maintain one more result variable over here is equal to what, so we can get the power, right guys? So 1 to the power 3. So how will you get the power, right? So I simply say that the result is equal to result plus, I'll be using this math function dot power, and whatever the reminder that you are getting n power of 3. Let's see, like this. Okay, the power of 3 over here, and we're using it. And simple math dot this, and this result what we are taking, okay, cast to integer, or I'll be taking a double number over here. Yeah, because it will return double. And okay, 1 second, I need to initialize some number over here like this. So let's see, double, or I'll be taking 1 second, integer result is equal to initialize with 0, and remove this double from here. And now it's saying that okay, so I'll do one thing, let me make it double only. Okay, perfect. So result equal to, initial result was 0, result plus math dot power n to the power 3, and then whatever the actual number that you are getting, actual number is equal to actual number divided by 10, that you have to divide by 10 also, like this. Okay, so rest of the logic will remain same. So what I'm doing is, first I'm getting the reminder we will be getting 3, and 3 to the power 3, that is what I want. And then I'll the next time number will be divided by 10, number will be 15. I'll be getting the reminder as 5, 5 to the power 3, and finally I'm getting number 1, 1 to the power 3, and I'm keep adding them in the result. And if I say that okay, if I put one condition over here, and whatever the result that you are getting, which is equal to what, the number, the original number that you are talking about, it means system dot out of println that number is an Armstrong number. Okay, else not an Armstrong number. Perfect. So let's run it and let's see. So 153 is an Armstrong number. Let me check. 371 is also an Armstrong number. Yes, perfect. This is also fine. Let me check. 374 is not the Armstrong number. It's not an Armstrong number. Okay, so likewise, simple, you can do that, guys. Simple is an Armstrong number. Okay. Now, next question. Armstrong number between two intervals. So there are two intervals are given, and you have to find out the Armstrong number. That is your assignment, that you guys do it. Okay, so Armstrong number I have already told you, between two. Okay, you have to do that. Same thing, prime numbers between two intervals using function. Okay, you can create a separate function that you guys do it later. I'm not going to tell you. So I'm just ignore prime number and Armstrong number question that we have already covered. Similar kind of the concept, you have to use that. Now display factors of a number. Factors of a number. Okay. If the number is 4, what are the different factors are there? Okay, got it. It's difficult to recall all the things. So let's see factors. So question is find out all the factors of a particular number. If I'm saying that okay, the number is 10, so number 10 is divisible by what? 1, then 2, then 5, and then 10. So these are the factors of that particular number. If I say that okay, number is 60, so what are the divisors? 1, 2, 3, 4, 5, 6. It's not divisible by 7, 8, no, 9, no, then directly 10, yes, 10 multiplied by 6, 60, then 12, then 15, then what, 20, then 21, 2, 3, no, 30, 30 to 40 range, 50 range, no, and directly 60. Yeah, so these are the factors of 60. Likewise, how will you find out? So very simple. Let's see, I'll take one variable, number is equal to 60, and I'll create a for loop int from where we have to start. Obviously it will be divisible by 1, so I have to start from 1, and I less than equal to what? Less than equal to that particular number, and then I plus plus. Very simple program. And I put one simple condition that okay, if your number and modulus I is equal to 0, it means if that particular number, I'll keep increasing the value of I, and the remainder is coming equal to 0, it means it's totally divisible with that particular number. And I simply say that okay, yeah, that is mean that is a factor of that particular number. I simply say that okay, that I is a number. I put a space over here to print it like this. So the factors of 60, it will print. You can see that okay, the same thing, 1, 2, 3, 4, 5, 6, 10, 12, 15, 30, 60. Perfect. Now I'll check the factors of 10. So the factors of 10 will be 1, 2, 5, 10. Perfect. So this is a simple question, guys. So don't be confused. It looks a little scary, but simple logic you have to write. You have to keep checking that with the I, the remainder is equal to 0. Then only that is a factor I got it. Okay. It means we have found the factor, which is totally number is totally divisible by that particular number. Okay. Likewise, you can simply do that. Okay. You want me to cover some more? Okay, let's do that. One more thing, we will do that. Java program to make a simple calculator using switch case. Okay, calculator we have to design. So in calculator we have majorly 4 operations: plus, minus, multiply by, and division. So let's design this. I know this is the question generally people ask, to implement only 4 operations. So how will you design that? So with the help of what? With the help of switch case statement. Okay, so I simply say that okay, calculator, select the main method, click on finish, and let's write something over here. So make sure that okay guys, we have to use what? Switch case. So I'll do one thing. I'll be asking at the runtime through the scanner class that a scanner reader is equal to new scanner, and then I'll be writing system.in over here. Okay, and you need to import this from java.util package scanner. After that, what I have to, I've asked that okay, hey, please enter the number. I simply say that okay, enter 2 numbers that we need to ask, right? Let's see, 1 and 2. So and then which operation? 1 plus 2 is equal to 3, right? Like this. So enter 2 number, then we will be asking, and then I'll be asking that okay, enter the operator also, like plus, minus, multiply by, and divisible. So I'll do one thing. I'll maintain double. Why? Because The number could be point values also and integer value also. So I'll say that, okay, my first number is equal to what? Whatever the reader dot the next double that you are asking, and I'll be asking that same thing for second number. Okay, like this. So first equal to this and second is equal to this. And then I simple say that, okay, system dot out dot println, I simple say that please enter an operator. Which operator? So I simple say that, okay, operator means, let's see, it could be plus, it could be minus, it could be multiply by, and it could be a division number. So I'm asking that, okay, hey, please enter these things. Which operator you want to select? Okay, then I'll select the operator. So operator will be in character. So I simply say that, okay, reader dot next dot character at 0th position. So whatever the character that you are passing and store in that particular character. And let's see, this is my operator is equal to this. Okay, so let's say if I'm passing plus, so from that particular plus, 0th position you pick, it means plus you pick and store in this particular operator. Okay, now I'll be maintaining my result also, right? We have to maintain to store the result value. 1 plus 2, 3, and 1 multiplied by, or 2 multiplied by 4 equal to 4, something like this. And then I'll be maintaining my switch case statement over here. In my switch case, what will be my key? Key will be my operator, right, guys? And then I'll be writing my case over here. If my case is plus character, then what I have to do? It means my result will be what? Result is equal to what? Simple. First plus the second number that you have maintained over here that you have already read it from, okay, from the console, and then you simple break it. Then I'll be using my second case, third case, and fourth case. So these four cases I'll be using plus, then minus, then I quickly write multiply by, and then I'll be using what? I'll be using with division. So these four cases I'll be using, and then first minus second, first multiply by second, and first division by second. And then in the default, I simple say that, okay, I print a message that system.out.println, please pass the correct operator. If nothing, any of them operator is not selected, simple. Okay. So when you get it, then what you have to do? I simple something like this, system.out.println, and I'll print the result over here. Okay. So print the result, initialize the value, result equal to 0. Fine. Okay. Shall I run it? So what I have done, first I'm asking the two numbers, okay, in first and second variable. So let's run it, and it's saying enter two numbers. So I'm entering the two numbers, guys. Let's see, 10, and the second number is 20. And it's saying please enter an operator. So I'll be asking an operator. My operator is plus. Perfect. And it's saying 10 plus 20, 30. Awesome. Perfect. Now let's do some other operation. Enter two numbers. So I'll be saying that 30 divided by 5. I'll be saying that this division 6. See, I created a calculator, a simple 4 operators calculator. I have created that. Now let's run it again. Let's check some other operations. I say that, okay, 20 and 5 and multiply by this 100. Perfect. So I simple print it like this, 100. Okay. Now let's take some other calculation, minus also. So let's see, I'm passing 10, 200, and operator I'm selecting minus. I'm getting 10 minus 200 minus 190. Okay, so it's giving you obviously 10 minus 200 minus 190. Perfect. So it's absolutely working fine, guys. You have to take a double number as a result, guys, because when you do the multiplication with the point values, you will be getting in double only. So let's see if I'm passing something like this, 1.2 and 3.34.44. multiply by this, so you will be getting this. So if you're maintaining only integer, you will be getting only 41. So that's why to do a proper calculation with respect to calculator, you have to use a double result over here. Okay, and everything you have to calculate with respect to double instead of integer. That is what most of the people they do the mistake. Okay, so this is also done. Okay, so next question we will do it later, guys. Whether a number can be expressed as a sum of two numbers. Okay, that we can do it later using recursion and all those things. Okay, these things we will do it later, not now, guys. So I think that is enough for this particular video. How many things we have covered? Three plus. No, we have to start it from here. So we have this 5 plus 2, 7 programs we have seen in this particular video. So I'll be keep doing all these things, guys. Don't worry about that. Okay, it will take some time. It's not like within one day we can cover everything. It will take time. So I'll just keep uploading the videos about this. I hope you guys are enjoying this. So please do it, guys. It looks very easy, but at a time of interview, someone is asking you randomly, you have to think about it. Okay, and if you're giving the wrong answer for these small questions, then it doesn't look good, right? So thank you so much, guys. Thanks for watching this video, and let me know if you have any issues.